Overview of computer programming. When one comes across this topic, it is important that one asks oneself what a computer programming is. But to start with, one needs to know what a computer program is and therefore build on top of that. Right now, right here, we shall answer these interesting questions and even more. So stick around and enjoy. Program, computer, A is what? Read the question for yourself. Well, a computer program is a sequence of instructions that tell a computer what to do. Simple. Example is the operating system we saw earlier, which tells the computer how to perform. Another example is the calculator in your laptops or your mobile phones, which tell the computer how to perform arithmetic. Who doesn't know what a laptop is? Raise up your hand. Wow, I can imagine. Well, laptop is another name for bread. There are a million examples of computer programs. In fact, the software components we once talked about are computer programs. Hopefully, in no time, you too will get to write your first computer program. This is you we are talking about. Commanding the computer on what to do. What a superpower. Well, you stop blushing. Now, computer programming is simply the process of designing or building computer programs. By the time you write your first computer program in this course, you must have done computer programming. A programming language is any language that is used to write computer programs. At least you can outline the relationship now, right? Well, examples of these programming languages are Java, which we shall study momentarily, C++, Python, JavaScript, Ruby, PHP, Perl, Swift, Visual Basic, to list a few. And at this point, I bet your intuition has already told you who a programmer is. Well, a programmer is simply who uses programming language to tell computer what to do. A programmer is one who solves problems. Just as Mark Zuckerberg came to our rescue by creating Facebook, which solves the problem of remote communication. You might have observed that I like using hierarchy in my slides. Reason is that not only do I want you to understand the individual terminologies, but also the relationship that establishes between them. This hierarchy explains the three different categories or levels of programming language. On one hand, we have the low-level programming languages. On the other hand, we have the high-level programming languages. Under the low-level programming languages, we have the machine language and the assembly language. Machine language is typically the crude zeros and ones that computers understand. In this category, a programmer writes a continuous stream of zeros and ones that are meaningful to the computer in order to build a program. Imagine writing your name as 11001100 or some sort of jargons of its kind. This can be daunting and overwhelming, really. And bring it on, in our previous lecture we learned that different CPU families understand different languages. This is what makes the machine language even more insane and exhausting. You have different ways to represent just your name across the diverse CPU families we have. This is ridiculous. But in contrast to all that I have said about machine language, it has advantages. Measure one of which is speed. Once a program is written, it needs no translation. It executes right away, and that makes it efficient and effective. But speed isn't all that matters. Simplicity does too. And that paved the way for a simpler category, which is the assembly language. Assembly language allows for mnemonics, which are abbreviated words that correspond to machine language. For example, the mnemonic MOV is an abbreviated form of move, which tells the computer to move a piece of data from one memory location to another. No other way about it, the computer understands no more than the machine language. Therefore, these mnemonics and other things that form the assembly language needs to be translated to machine language. This is where the assembler comes into play. Assembler is a piece of program that translates assembly language to machine language. In this strive to enhance simplicity, some sacrifices were made, really. One is that speed was somewhat compromised, but who cares? All that was desperately needed is simplicity. And indeed, assembly language made computer programming easier than the earlier gibberish. Things changed for a better, but certainly not for best. There was still a withering problem faced by programmers, which was each CPU family has its own assembly language. And for that, it was still hard to have solutions for problems. Henceforward, the compelling urge for simplicity and user-friendliness continued, and gradually over the years, then built the high-level programming languages. High-level programming languages are written in a form that is very close to human language. This category made computer programming very simple, so that a programmer can focus 90% in solving the problem rather than the programming language. And this opened the gates to a creative generation. High-level languages are generic and flexible as they are one across all CPU families. They are technically translated to the machine language of the computer they are executed in. And this longer process of execution makes high-level languages slower than even the assembly language. High-level programming languages are either translated by a compiler or an interpreter. Just like assembler, compiler and interpreter are computer programs that translate high-level programming languages. Though both interpreter and compiler do the same work, which is translating high-level languages, they are still different in terms of operation. Interpreter translates program at runtime, one instruction at a time. At runtime means only when the program gets executed does the interpreter work. It translates and executes one line of instruction before it then goes to the next line under it. Examples of the programming languages that get interpreted are the famous Python, JavaScript, Ruby, PHP, etc. Interpreted programming languages are also called scripting languages. Therefore, Python is a scripting language. As for the compiler, it translates at compile time. This means the entire program gets compiled first, then everything gets executed at once. Examples of the programming languages that get compiled are Swift, Visual Basic, C++, Fortran, etc. Think of it, high-level languages are called so because they are understood by humans, while low-level languages are called so because they are understood by machines. And since it's human that made machine, that is as it should be. High-level language, low-level language. This table shows example of how one same instruction is written in the three different categories using 8086 CPU family. Assume x and y to have any possible value. Therefore, the new value of x equals the value of x plus the value of y. So in assembly language, this single instruction needs to be broken into three instructions, starting from the instruction MOV AX, X. MOV, as I said earlier, is a mnemonic that means move a piece of data from one memory location to another memory location. AX here is a special register that means accumulator. I said this in our very first class, you remember? Good. So the instruction means move the value of X into the accumulator, while ADD means addition, sum, or plus, whatever you call it. AX still remains accumulator. Hence, this instruction means add the value of Y to the accumulator, which is already holding the value of X. At this point, it should be clear that the addition has occurred, only that the value is stored at the accumulator, and that's not where we want it. If you look at it here, we can see our value is stored in X. So to achieve that, we simply say move whatever it is in the accumulator, which is the sum of X and Y, to X. Now X is holding our results. And finally, what happened here is exactly what happened here. This line means this line. This line means this line. This line means this line too. You can see how difficult this can be. Hopefully this has shown you how easy the high-level language is compared to its predecessors. This is all for now. I hope you really enjoyed it. Let me know in the comment section if you have any question at all. See you in the very next one.